Second step, that is the extraction of metal. Now this is the flow chart of extraction of metal. That is a metal of high reactivity, then metal of medium reactivity, and then metals of least or less reactive. So extraction of high reactive metals, how it is done? Now in this case, the reactivity series, here you can see the most reactive metals like potassium, sodium, calcium, magnesium, aluminum. Then medium reactive metals like zinc, iron, tin, lead, hydrogen, and less reactive metals are copper, silver, gold, and platinum. So the first we'll see about, that is the aluminium, extraction of aluminium. The extraction of aluminium take place in two methods. That is a concentration of bauxite ore, and second, that is the electrolytic reduction of alumina. How the concentration of bauxite ore is done? Just watch this video, you'll understand. The two methods are there: concentration of bauxite, that is a Bayer's method, and second is a Hall's method.
Extraction of reactive metals. Metals placed on the top of the reactivity series are highly reactive. For example, potassium, sodium, and aluminium. Reactive metals have a large capacity to form cations by losing electrons present in their outermost shell. Reactive metals react vigorously with dilute acids to liberate hydrogen gas. Highly reactive metals burn by reacting with oxygen from the air, even at room temperature. Reactive metals usually occur in the form of their oxides or chlorides. The process of electrolytic reduction is used to obtain the metal from the metal oxide or the metal chloride. The metals, sodium, calcium, and magnesium, are obtained by the electrolysis of their molten chlorides. In this process, the pure metal is obtained at the cathode and chlorine gas is obtained at the anode. For example, in the electrolysis of molten sodium chloride, sodium metal is obtained at the cathode and chlorine gas at the anode. In the electrolysis of molten magnesium chloride, magnesium metal is obtained at the cathode and chlorine gas is obtained at the anode. In the electrolysis of molten calcium chloride, calcium metal is obtained at the cathode and chlorine gas is obtained at the anode. Similarly, aluminium is also obtained by the process of electrolytic reduction of its oxide. Let us first understand how the metal aluminium is extracted from its ore, bauxite. Extraction of aluminium. Aluminium is a silvery white metal. Its symbol is Al and it belongs to group 13 of the periodic table. Its atomic number is 13 with electronic configuration 283. Aluminium shows a fixed valency of 3 in its compounds. Aluminium is a reactive metal. It occurs as an oxide in nature. Aluminium is the third highly abundant element in the Earth's crust after oxygen and silicon. The most important and common ore of aluminium is bauxite, which is hydrated aluminium oxide, that is Al2O3NH2O. The ore contains about 30 to 70% of aluminium oxide. The remaining portion is gangue, which is made up of sand, that is silicon dioxide, and iron oxide. The extraction of aluminium involves two steps. The first step is the concentration of the ore, and the second step is the electrolytic reduction of pure alumina. Step 1. Concentration of the ore. Bauxite is the main ore of aluminium. It contains the impurities silicon dioxide, that is SiO2, ferric oxide, that is Fe2O3, and titanium oxide, that is TiO2. The concentration of the ore involves the separation of these impurities by leaching and conversion of bauxite to pure aluminium oxide or alumina. This process used here is called Bayer's process or Hall's process.
Now the concentration of bauxite is done by two methods, Bayer's process and second Hall's. आता बेअर्स प्रोसेसमध्ये काय केलं जातं की सुरुवातीला बॉल मिलमध्ये या ठिकाणी ते मटेरियल क्रश केलं जातं बॉक्साईट. नंतर त्याचं लिचिंग होतं, त्याला हीट केल्यानंतर कॉन्सन्ट्रेटेड सोडियम हायड्रॉक्साईडबरोबर त्याची रिॲक्शन केली जाते आणि टेम्परेचर 140 to 150 डिग्री सेल्सिअसपर्यंत त्याला गरम केलं जातं आणि हाय प्रेशर देऊन 2 ते 8 तासापर्यंत त्याला डायजेस्टरमध्ये त्या ठिकाणी हाय प्रेशर दिला जातो. आता ॲल्युमिनियम ऑक्साईड हा ॲम्फोटेरिक नेचर आहे, म्हणजे तो सोडियम हायड्रॉक्साईडवर रिॲक्ट होऊन वॉटर तयार करणार, सोडियम ॲल्युमिनेट साल्ट. म्हणजे या ठिकाणी Al2O3 आणि H2O त्याची सोडियम हायड्रॉक्साईडवर रिॲक्शन झाल्यावर सोडियम ॲल्युमिनेट आणि वॉटर तयार होणार. नंतर हा आयर्न ऑक्साईड जो आहे गँग्यूमधला हा सोडियम हायड्रॉक्साईड बरोबर डिझॉल्व होणार नाही आणि मग फिल्टर करून तो सेपरेट केला जातो. त्याचप्रमाणे गँग्यूमधला जो सिलिका आहे हा डिझॉल्व कोणाबरोबर होणार, सोडियम हायड्रॉक्साईड बरोबर होणार आणि त्याच्यापासून वॉटर सोल्युबल सोडियम सिलिकेट मिळणार. आता हे ॲक्वेस सोडियम ॲल्युमिनेट हा डायल्यूट केला जातो पाण्याबरोबर आणि त्याचं टेम्परेचर कूल केला जातो 50 डिग्री सेल्सिअसपर्यंत आणि त्याच्यापासून आपल्याला प्रेसिपिटेट मिळणार. तो प्रेसिपिटेट होणार ॲल्युमिनियम हायड्रॉक्साईडचा. म्हणजे रिएक्शन कशी होणार, NaAlO2 + 2H2O त्याच्यापासून NaOH + AlOH थ्राइस. सो दिस इज द बेअर्स प्रोसेस.
In the Bayer's method, the bauxite ore is first crushed in a ball mill and is leached by heating with concentrated sodium hydroxide or caustic soda under high pressure for about 2 to 8 hours and at a temperature of about 140 to 150 degrees Celsius. This process is carried out in a tank called a digester. Aluminium oxide of the bauxite ore is amphoteric in nature. That is, it can react with an acid as well as a base to form salt and water. It therefore reacts with aqueous sodium hydroxide and dissolves in it to form water-soluble sodium aluminate. This process is called leaching of bauxite by sodium hydroxide. Sand or silica present in the gangue also dissolves in aqueous sodium hydroxide to form water-soluble sodium silicate. Iron oxide in the gangue does not dissolve in aqueous sodium hydroxide. It is then separated by filtration. The filtrate now contains aqueous sodium aluminate and water-soluble sodium silicate. The filtrate is now diluted with water and then cooled to 50 degrees Celsius. At this stage, sodium aluminate gets hydrolyzed to form aluminium hydroxide. In the Hall's process, the ore is powdered and leached by heating with aqueous sodium carbonate to form water-soluble sodium aluminate. This process takes place in the digester. The impurities present in the ore do not dissolve in sodium carbonate. They are separated by filtration. The filtrate is warmed and neutralized by passing carbon dioxide gas through it. This results in the precipitation of aluminium hydroxide. aluminium hydroxide, which is obtained by both the processes, is filtered, washed, dried, and ignited at about 1000 degrees Celsius to obtain pure aluminium oxide, which is also called alumina. This method is called calcination. The next step is the electrolytic reduction of alumina.
Now this is the Bayer's process, Hall's process. Then second step, that is the extraction of aluminum, that is the इलेक्ट्रोलिटिक रिडक्शन ऑफ ॲल्युमिना. आता इलेक्ट्रोलिटिक रिडक्शन ऑफ ॲल्युमिना म्हणजे या ठिकाणी एक स्टीलचा टँक असतो, त्याची इनर लाईन ही ग्राफाईटने केलेली असते आणि त्याच्यामध्ये ग्राफाईटचे 3 असे इलेक्ट्रोड इमर्स केलेले आहेत आणि त्या ठिकाणी ही इलेक्ट्रोकेमिकल रिॲक्शन होऊन त्या ठिकाणी आपल्याला ॲल्युमिनाचा ओर आपल्याला त्या ठिकाणी मिळणार आहे. म्हणजे कॅथोड रिॲक्शन आणि ॲनोड रिॲक्शन होणार. चला आता जेवण करूया आणि मग 11 मिनिटाचा आहे तिथंच ठेवतो त्याला.